Hi, welcome to Nomis Academy. This time we'll be dealing with problems on sets. Problems on sets. Problems on set theory. Problems on set theory. So in a dancing competition, each competitor could dance to at least one brand of music played. Two brands of music were played that day. Okay, 10 of the competitors could dance to Fuji music, while 14 of the competitors could dance to jazz music. If 4 of the competitors could dance to both brand of music, find Roman figure 1 the number of the competitors that could dance to Fuji but not to jazz, the number of the competitors that could dance to jazz but not to Fuji, and the total number of people involved in the competition. So you can see this kind of questions and you think, how do I get to know the number of people that were involved in the competition? I think it's clear that since 10 people could dance to Fuji and 14 people, maybe there are 24. If you had guessed like that, you will be very wrong. You need to do calculation using set theory, especially the Venn diagram before the set theory, to make your analysis, and then you get the correct answers to the questions asked. So let us begin by interpreting the questions on a Venn diagram and then putting down the given parameters out to think of what to do. So the first thing is, let's make a Venn diagram. So this be our so since it's a set of two brand of music were played, so we have two set. Let's say set A and set B. So we have set. So let's take this rectangle represents the universal set. So while each circle inside represents um, each set. So two brand of music were played that day. 10 of the competitors could dance to Fuji. So let's take this to be the set of Fuji, set F, while 14 of the competitors could dance to jazz. So that is J. So this is set J. So set F and set J. Now, if 4 of the competitors could dance to both brands of music, so meaning that there's an intersection common elements. If 4 of the competitors could dance to both brands of the music, so we have a 4 here, but we don't know F. That is, F is the people that dance to Fuji only. Only was not mentioned in the question, and to jazz only was not mentioned in the questions. We only know that 4 plus a particular number of people dance to Fuji, and then 4 plus a particular kind of people dance to jazz. So we are going to find out by our analysis. So this is going to be X, and this is going to be y. Now let's get into finding out the value of x, the value of y, and the total number of the people involved in the competitions, because that's the questions. The question says the number of the competitors that could dance to Fuji but not to jazz. So that is the x value. And the number of the competitors that could dance to jazz but not to Fuji, that is the y value. So let's get into it. Let's read the question again and then begin to find our answers. In a dancing competition, each competitor dance to at least one brand of music played. Two brands of the music were played that day. Now, from here, let us be careful to take our parameters. 10 of the competitors could dance to Fuji. 10 could dance to Fuji. So, if I will need to talk about Fuji, that is F. So, I will need to tell that those that could dance to Fuji were X plus 4, but all of them are equal to 10. What's the value of x? So x now is equal to 10. 4 goes to the other side, becomes minus 4. So that means the value of x is 6. So 6 people dance to Fuji only. So 6 people dance to Fuji only. Now let's find the value of y. Said while 14 of the competitors could dance to jazz music, 14 of the people. So I will say y, that is for j. So y plus a particular plus 4 is equal to 14. So that will now be y equals 14 minus 4. So we have 10 people who dance to jazz only. So we have 6 of these people who dance to Fuji only and 10 people who dance to jazz only. So we've answered Roman figure 1, the number of competitors that could dance to Fuji but not to jazz. That's the value of x. The number of the competitors that could dance to jazz but not to Fuji, that's the value of y, and we've gotten y to be 10 only. Now, the total number of the people involved in the competition. So, the total number of the people involved in the competition, how do we get that now? So, the only way we could get that is that we are going to add Fuji only, jazz only, and the common elements. So, the total number of the people involved in this competition is now equal to x plus 4 plus y, and since the value of x is 6 plus 4 and the value of y is 10, so we have 6 plus 4, 10, 10 plus 10, 20. So there are just 20 people involved in the competition. So if you had guessed, thinking that okay, if 10 people could dance to Fuji and 40 people could dance to jazz music, maybe there were 24 people, you see that you would have gotten it wrong. You don't think of people who could dance to Fuji and could still dance to what do we call it now, jazz. So we can see that there are just 20 people involved in this competition entirely. Set notation. So let's get it. So if I'm looking for the value of x, that the value of x, yes, so that means x, which is equal to 10 minus 4, is, let's go to the next page. That means x would be f union y complement. union y complement. So when I go there, I'll have f union, x union x union y complement. So it will be f so it will be f, that's set f union j complement. So union j complement. Now what do we mean by complements? And that means that we are only dealing with f now plus other elements that are not in j. Other elements, so j is totally excluded. So whether you could dance to Fuji and dance to jazz, we are less concerned about you, since you are not just only Fuji. So Fuji is just f and f union, that is plus now jazz complement, that is anything that does not involve jazz. So that is the interpretation of our value of x. So x is f union j complement, f union j complement. So let's take the value of y. What about y? How do we interpret y? So y is equal to, since we are dealing with just only j and f is totally not involved, even though we have some that are in jazz that are still in f, so we will not count them as only j. So since as only j says, since we are dealing with just only j, then we just say j union f complement, j union f complement, and that's the value of y. And then what about this 4 now? How can we represent this part that is carrying 4? Remember that this is an intersection. This is where f and j intersect. So this 4 is a value of f intersect j. So that is f. So the value of 4 is equal to f intersect j. So that's the value that we just found. So that means f union j complement is equal to 6. J union f complement is equal to 10, and f intersect j is equal to 4, and that gives us the totality of what we are looking for. So that is just 20. So there are just 20 people involved in the competition. I hope you understood everything you learned in this video. If you need to watch it carefully, get your notes noted, and solve more questions on set theory. Bye bye. See you in the next video.